AOPS number theory 2.10. Each week, between 30 and 50 students show up for an archery class run by Betty and Wilma. Usually the students break up into groups of equal size for target practice. However, this week Betty noticed that she could not break the students up into multiple groups of equal size. Wilma noticed that if Betty and Wilma joined the students in practicing, they still could not break the archers up into groups of equal size. How many students showed up the archery class this week? So, if they could not break up the students into multiple groups of equal size, that means that the number of students is prime. So let the number of students be n. So n is prime. And if Betty and Wilma join as well, they still cannot break it up. So n plus 2 is also prime. And since it says that it's in between 30 and 50 students, then we just test all the prime numbers we test all the numbers in between 30 and 50 and see if there are two consecutive prime numbers if there are two prime numbers that have a difference of 2. So we are going to list all the prime numbers in between 30 and 50. Yeah, so that's all the prime numbers in between 30 and 50. So if we see 31 and 37, the difference isn't 2. 37 and 41, the difference also isn't 2. 41 and 43, the difference is 2. So it could be 41. There could be 41 students. So n can be 41. And if we test if any other numbers work, it won't work. So 41 is the only possible value for n. So 41 students showed up. AOPS number theory 2.11. What is the largest two-digit prime number whose digits are also each prime? So first we're going to list out all the single-digit prime numbers. That's 2, 3, 5, and 7. And since we want the largest two-digit prime number whose digits are also each prime, we should probably start with the tens place being 7, because that's what would make it the largest two-digit number. So if we try 77, that would be it's divisible by 7 and 11, so it's not prime. So then if we try 75, that's divisible by 5 and other stuff, so it's also not prime. And then we try 73, and that is prime. So 73 is the largest two-digit number whose digits are also each prime. So 73 AOPS number theory 2.12. How many prime numbers are perfect cubes? So If a number is a perfect cube, that means it can be written as n to the power of 3, which is also equal to n times n times n. And the definition of a prime number is that it's only divisible by 1 and itself. So if that number can be written as n times n times n, then it's not only divisible by n in itself, so it wouldn't be prime. So the answer is 0.